Today we are going to discuss about the potentiometer. See, potentiometer is an electrical instrument which is used to measure an unknown EMF. EMF of a battery. First, unknown EMF of the battery or potential difference of a battery accurately. So this is the potentiometer. Now we are going to see what is its construction. It has got a long wire uniform cross section, long wire of uniform cross section AB. This is the wire A to B. Long wire uniform. It has a long uniform wire AB of 4 equal parts made up of Constantine or magnet stretched on a wooden board. See, 4 meter, 1 meter, 2 meter, 3 meter, 4 meter. See, 1 meter connected here through a copper strip, and again it is connected here, another meter, another. Usually 4 meter. It may be 10 meter also. So 4 meter, 1 meter, 1 meter, 1 meter. It is connected through copper strips. So the length AB is usually 4 meter long. The material of wire should have high resistivity. Material of the wire what it should have high resistivity. It should have high resistivity, and what else? Regarding the temperature coefficient, it should have the high resistivity and low temperature coefficient. Low temperature coefficient of resistance. Low temperature coefficient of resistance. Usually, 4 1 meter long wire is fixed on wooden board parallel to each other. This is 1 meter, 1 meter, 1 meter, 1 meter are parallelly fixed on the copper strips. Usually 4 1 meter long wire is fixed on wooden board parallel to each other, and there is along with this there is a 1 meter scale is also fixed on this wooden board, so that we can measure the length. With this help of the scale, we can measure length from here to here, or from here to here, or here to here. We can measure the length on the wire. The wires are joined in series by thick copper strip which has negligible resistance. What does that mean? The wire, this wire, they are connected by copper strips, so this wire is continuous. Why it is continuous? There should be resistance of the copper strips, but the resistance of the copper strip which has a negligible resistance, that's why this point and this point are continuous. It means it is a continuous wire. The wire is connected as good as connected in series. A meter scale is fixed parallel to this wire. Okay. Now end A and B are connected. Now end A and B. Now they are connected. A and B, it is connected with a battery, an ammeter, a rheostat, and a key. Why this ammeter? Ammeter shows nothing but current through this circuit. So from A to B, this is called a driving circuit, and A and B are connected with a battery, a key, and a rheostat. This circuit is called driving circuit. A jockey from A, this is connected, a jockey through a sensitive galvanometer is connected, which can move on the wire. We can move it here also, here, anywhere. So the end A and B are connected. So the jockey J through sensitive galvanometer is connected from point A, which can slide along the length of the wire. Now when the key is pressed, we press this key, what happens? See, when this key is pressed, the current will flow like this. Or we can take the simplified circuit. See, simplified from A, battery, ammeter, rheostat, and key. When key is pressed, the current will flow like this. By fixing the a resistor here, because this is variable resistance, we connect a suitable resistor here so that current will flow constant, because I is equal to, by Ohm's law, V by R. If we are fixed, this is fixed and this voltage is also fixed, it means current will be constant. Constant current will flow in the circuit. Now, when the key is pressed, constant current is flowing in the circuit. So, we will see how it is working. Constant, okay. So, the current, constant current, this is wire. This wire is of uniform cross section. The wire is of uniform wire. That is the wire, constant and wire through which the current is flowing. This wire is constant, uniform cross section. What do you mean by uniform cross section? The cross section, area of cross section at every length is exactly same. The potential drop across any length, suppose potential between this length or this length, potential drop across any length, the potential drop across any length of the potentiometer. Potential drop across any length of the potentiometer is directly proportional to the length. What does it, how we prove it? The potential drop is directly proportional to the length. Suppose if you move the jockey here, the potential will drop. Why it is dropping? See, now we take this one from A to B. A battery is connected. Say if it is 5 volt, here 5 volt is available. Slowly the potential will be reducing, here will be 0 volt. It means at this point it may be 3 volt, it may be 4 volt. It means there will be a decrease in potential when we move from point A to B. So therefore, when key is pressed, a constant current flows through a wire of uniform cross-sectional area. The potential drop across any length of the wire is directly proportional to that length. So, if the potential difference between A and the jockey, suppose let us take the potential difference between A and the jockey, we are moving the jockey like this. We can move anywhere from point A, it is connected through a galvanometer, we can move it anywhere. Now, let us assume we are moving and we are stopped here, and the length is equal to L and the resistance from here to here of the wire is equal to R. The potential difference between A and jockey, the potential difference between point A and the jockey position is equal to potential difference is equal to V. We call it as V. Where R is the resistance. R is equal to a resistance. R is equal to resistance of this length of the wire. So Ohm's law, what it says? By Ohm's law, V is equal to I into R. This is V into, and we know V is equal to I. Resistance is equal to resistivity into length of the wire into area of cross section of the wire. That is, resistivity is R. We can say V is equal to I rho by A into L. We can write, because the current, constant current is flowing through the circuit and the resistivity of this material, this wire is constant. The area of cross section of the wire is also constant. Why? Because it is of uniform cross section. So these all are constant. So V is equal to constant, a constant into length, or we can say potential difference between this point and this point, between point A and the jockey's position is proportional to L. It means this is the basic principle of potentiometer. When key is pressed, a constant current flows through a wire of uniform cross-sectional area. The potential drop across any length of wire is directly proportional to the length. Okay, now we can call it as what where V is equal to, we can say V is proportional to, V is equal to as it is we have made it, V is equal to this much, and V is equal to constant, or V is equal to K into L, where K is equal to constant, whose value is this one. So V is equal to, we can write it again, V is equal to a constant into length, or V is proportional to N, where K is called, what we call the K. K is called potential gradient. Potential gradient. What do you mean by potential gradient? Potential gradient means the potential drop per unit length, that is K is equal to potential drop per unit length, that is K is equal to potential gradient, potential drop per unit length, per unit length of what? Potential drop per unit length of potentiometer wire, that is called potential gradient. And next is we will talk about the sensitivity of the potentiometer. What is sensitivity? Suppose sensitivity means the smallest potential difference. See, some instrument can measure only large potential difference. Suppose 5 volt it can measure. Suppose we want to measure 0.02 volt, the difference from this point to this point, 0.2 volt. That is called sensitivity of potentiometer. That is the smallest potential difference that can be measured accurately by a potentiometer. So sensitivity we can write the smallest. Sensitivity means it is the smallest potential difference that can be measured. Measured by whom? Measured accurately by potentiometer. Potentiometer is called the sensitivity of the potentiometer. See, as it is we have drawn the relation potential gradient, because by V is equal to I into R, V is equal to I into R, Ohm's law, or V is equal to I into R rho L by A, resistance is equal to rho L by A, resistivity, length of the conductor, and V is equal to I rho by A into L, and this is equal to V is equal to K into L, or we can say K is equal to V by L. Potential, so what we call is potential grade. K is called potential grade, which is potential drop per unit length of the potentiometer. So what is, we can draw, what is the relation? See, this is potential, this is length. What is the relation? Because as it is seen, V is directly proportional to the length, because this is a constant. It means how much this increasing, that much it will increase. It will be a straight line. So this we can call it as potential gradient. Potential gradient, nothing but slope of the potential and length graph. So what is the sensitivity? Sensitive means a potentiometer is said to be more sensitive. It means if it is having less potential grade, it will have more accuracy for the potentiometer. It means less sensitivity. This means accuracy. Accuracy will be more. This has to be small. That is V by L has to be small. Less the potential grade, more is the accuracy of the potentiometer.